We're going to go over automated GUI testing using froglogic Squish. Some of you may have used Squish before, where others may have not. As you know, or maybe don't know, we are headquartered in Hamburg, Germany. We were established around 2003 and are still privately held. For those in the US, we have had presence since 2009, and we have a large and growing customer base throughout the world. We've had steady revenue growth and been profitable since we were established as well. You also notice there's some companies you may recognize there. We have more than 3,000 companies currently using Squish throughout the world. Now, as this is more of a technical demo, I won't spend too much time on slides, so we'll go through these a little faster than usual, and we'll dive right into the demonstration. So Squish is an award-winning cross-platform multi-technology GUI automated testing tool. What does that mean? Well, Squish works across different operating systems or platforms, whether you're on mobile devices, Windows, Linux, or Mac. And then we support a number of different technologies across each of those platforms, which we call our editions. So today we'll be focusing on Qt, but you can see many others are also available. When working with Squish in the demonstration today, you'll notice that I'm using one of multiple scripting languages that we support: Python, JavaScript, Perl, TCL, and Ruby. So you do have the option of which scripting language to select. And then we also are known for our ability to work with multiple toolkits, so multiple technologies together, not just one technology standing alone, and we often call those hybrid applications or hybrid application testing. A little bit about the Squish architecture. When we are working in our Squish IDE, so that's where we're going to create our test scripts, we have our Squish Runner and our Squish Server, both services working with the Squish solution, which then communicate with your application under test, or AUT. So when you click record, the Squish server hooks into your application under test, allowing us to then see your objects, work with those objects as we work at the object level, finding and working with your application so that you can ensure that we're finding the correct objects. When we're executing tests, it's very similar. However, the Squish Runner is going to be used, whether you're using the IDE or just our command line interface or one of our integrations. The Squish Runner over a network will connect to the Squish server, which is, again, hooking into your AUT, communicating with it, and allowing us to both record and play back tests. Now, we do offer a number of different integrations, as well as a complete command line interface, and we do share our source code with customers, allowing them to then also extend Squish as well as create their own integrations. So enough slides. Again, this isn't a sales presentation. We'll go into the technical demo and get started here. So let's take a look at the Squish IDE. Again, any questions, please do enter them via the chat and we will help answer those. So you're taking a look at the Squish IDE right now. This is what it looks like when you first open it. For those of you who have worked with Eclipse, you may recognize it. It is built based on Eclipse. And when we're working with Squish, we have the concept of a test suite. Your test suite can be created to work in one of the 5 scripting languages that I mentioned earlier that we support. Today I'll demonstrate from a test suite that's in JavaScript, for example. And within your test suite, you'll have one or more test cases. Each test case has its own set of resources, whether you have test data or verification points. And then we also have the concept of test suite resources. So you have scripts, functions, data, or verification points, sometimes also known as checkpoints in the industry, common and available to all the test cases in your test suite. For those of you that have scripts external to Squish, if you're working in, for example, this is JavaScript, you have some JavaScript scripts external to Squish, you're able to use those by simply adding them to the global scripts area. Working in Python, Perl, TCL, Ruby, etc., the same thing applies. You can then use those scripts within Squish. So what do we see in front of us right now? Well, we see a script that I recorded, but how did I get there? I have my test suite, which your test suite simply created by clicking File, New Test Suite, and walking through a wizard, in which you also apply then the application you'd like to test, stored in our test suite settings. Now, once that's created, I simply click New Test Case, and I can click Record. That's going to launch the application I'm interested in testing. Now, it's important to understand that you may have a primary application you're testing or multiple applications you're testing. That doesn't mean you're just tied to one application. That's your primary application you're testing. You can switch between applications when you're working with Squish as well from a single test suite. So it launched my application. Now, because I want you to concentrate more on Squish and not on the functionality of the application under test, I've chosen a very basic application, just an address book here. So as I click through the address book, as I do anything with the address book, you'll notice this control bar here. I'll zoom in a little bit so you can see that. This control bar is going to let me see my status that I'm recording. It's also showing me any actions that I'm recording. This is not my email address, just in case you're wondering. So I'm recording some actions. Now, after you record a series of actions, oftentimes in automated testing, you also then want to verify that, well, the actions you recorded have the result you're anticipating. So your use case. That's when we return back up to the control bar up here, in which I can then create here three types of different verification points. So the first type of verification point that I may create would be an object-based verification point, looking at and inspecting at the object level any object in my application. Now I also have the opportunity or ability to create screenshot-based verification points. Maybe I want to verify the look and feel of an individual object or the entire application. We still find that object based on the object properties, and you're able to set thresholds as between different operating systems there may be variances in how the graphics appear. And then we also have table-based verification points, the ability to verify the contents of an entire table at one time instead of working through at a row or column level. Now, it's important to understand no matter what type of verification point we're creating, we're always finding these objects using the object properties, and we'll get into that a little bit more. So before I click here, once I click on this button here, that's going to return me back to Squish. It's as if my script is paused. I'm not recording because I'm not performing actions against my application. And then I have the ability here to name the verification point in the event that I want to save this as a test case or test suite resource so that I can quickly and easily reuse that verification point throughout any test case. Or I can have here, instead of that one, the script-based verification point where it simply inserts this verification point as lines in my script. Now, how does it know what to verify? Let's take a look down here at the application objects. We can see this is the tree of the entire application. Now, might not be that easy to go and dig through and find things, but what we have here is an object picker, much like anyone that's used an object spy tool or anything. I select the object picker, and that's going to return me back to my application, where, as you'll notice, as I hover over different objects, I can see information about those objects, kind of a tooltip to help me understand, okay, if I click on this, that's what I'm going to verify. So for example, if I verify this particular column, I simply click on it and that returns me back to Squish, where I can see, instead of looking at the entire object tree, the object I'm interested in. From there, I can navigate up and look at parent objects. If this object had any child objects, I would be able to expand the tree and see that as well. But what I'm interested in, because I'm interested in this object, are the properties off to the right. So with these properties, I'm able to see all the objects or properties of this object in this particular selected object. So for example, let's start basic here. I want to verify the text of this object. Perhaps I also want to verify the row in which this object appears. So as I check these different properties, you can see they're then appearing as part of my verification point above. So from there, I can change the values, set them as expected failure, or simply insert the verification point and return to my recording. So let's click Insert. It's going to include that in my script once I click Stop, but here at this point I could continue recording whether I wanted to delete an item or simply exit the application. I'm going to click Stop and we'll see the recording that I created. Okay, a nice basic linear recording. Now I do see some questions being asked, so that's good. Please do feel free to ask any questions that you have, and we'll continue to field those. Okay, so taking a look at the script that was recorded. Remember, I selected JavaScript, so that's going to be the syntax you'll see here. However, no matter the scripting language you select, it's going to look similar. You're going to have similar things, such as items from the Squish API, start application. What does that do? Many times it's very intuitive and easy to work with. Starting the application. Here's the application it's starting. So it knows that name because that's a setting in my test suite settings. What did I do from there? I clicked a button. What button did I click? And you can see it just continues on just like that. I was using my zoom feature while I was recording. It captured that as well. That won't hurt the script, but it's also going to record it, the fact that I did that. That's just a tool on my computer to help during demonstrations so that you can see things a little more closely. Okay, so we're taking a look. Why don't we just play this back, show you that it plays back. Now, I will let you know over to GoToMeeting, it doesn't transfer as fast as I'm seeing it, so you will miss a few things, but to give you the idea, and then also you'll see this happen a few times. I'll run back some scripts multiple times here, and you can see the script executing. Obviously, it's not me performing the execution, as I cannot type that fast. Okay. So we run a script. Well, what happens? Remember our verification point that we created? That's down here. Test.compare. That's one type of many types of verifications that you can create. We have, like I said, an extensive Squish API all documented to help you in creating your scripts, whether you're recording or editing and creating them manually. Oftentimes the approach is more of a hybrid approach for recording as well as editing scripts. And we'll see that as we continue on here. So with this particular verification point, we said, okay, let's compare this object's text property and make sure the string is equal to Amanda. Well, how does it know what object to look at? So each of these objects in quotes here are what we call a symbolic name for an object, because we use like a nickname almost in your script so that if objects change in your application, the nickname or symbolic name is referencing the object in our object map. So if I right click on any object in my script and select Open Symbolic Name, I can also open the object map from here. It's automatically going to open up the object map to the object that I had selected in my script and show me that object. So remember, the symbolic name is most often used in your script. At times, what we call a real name can also be used in your script if you choose to do so, and you'll see some examples later of that. So what does this real name contain? It contains a collection of properties of that object automatically collected while you're recording. So this object map is built as you're recording, and it uses those objects that we feel are going to make that object unique. So based on our experience working with, for example, Qt objects, you can see this is a Qt object. We identify the properties, the minimum set of properties that are going to make this object unique. And then when we record and play, we are able to identify those objects using these properties. Now let's say you have things that change within your application. Maybe the name isn't consistent all the time. For example, if we take a look here, address book unnamed window. Think Microsoft Word, for example. Once you open an application, it's unnamed. The title bar then changes. Once you save that application, it has a different name. Same with Squish here. As I have different things open, that title bar changes, but it's the same object. How can we handle that? You have the ability, when working with objects, to either have a constant, so it's equal to that string, A wildcard so that you could look for anything, for example, after address book. Perhaps we simply want to have anything match after the word address book. Or let's say it's a more complex comparison that's required, you can incorporate a regular expression. So what that's going to do is allow your application to be dynamic, have these object properties be dynamic, and still be able to properly find those objects. Now, wildcards are used for objects where there may be some components changing versus if an object changes in its entirety, taking on all new names, you can still come to your object map, select Modify an Object. If your application's running, we'll see this later, you can check the object's existence and highlight that object, especially after performing changes in your object map, to make sure it's still finding the object you want it to find. Now, many applications, you never have to come and touch this object map. It's building those objects, it has them there, and you simply are able to work with the objects from the symbolic name in your script. Now, let's take a look at how this might look if it failed, because down here below, our verification point passed. So these are our test results. Amanda and Amanda are equal. Okay, great. What does it look like if it fails? Now, there's different things. There's a pass and failure of your verification point, and then there's also what's considered a scripting error, maybe a syntax error, or it can't find an object. So if I change this to Tom and we rerun this, we'll now see that this verification point is going to fail. It's going to say, okay, I found the object, but its text was not equal to Amanda as expected. So I'm going to have it expect being equal to Tom, but up above, remember we're entering it as Amanda. So again, we're starting off with a very basic case here. Expected result, actual result. But this then applies to your more complex cases. Amanda and Tom are not equal. Okay, so that verification point failed. Now, some other features to mention. When you encounter a failure, or I can break the script so that it encounters a scripting error, for example, you can have Squish capture a screenshot when a verification point fails, when a scripting error occurs, or you can simply capture a screenshot whenever you'd like throughout execution. Sometimes the collection of data from your script, so for example, collecting properties and sending them as a log to your test results, as well as an image, can provide you with more information. To add logging information to your script, again, we have this all documented within our documentation, but you can see here, test.log, what is my message I want to include, what is the detail I'd like to include, and that will then log that to my results when the test executes. The more you incorporate into your test results, the more value those results will have. Now let's take a look at another script. So this is a script very similar to the one I recorded before. Just very linear, right? Start at point A, go to point B, but those aren't the most effective scripts in automated testing. What we're going to have is repeat actions. We're going to have things that are common occurrences when you are building your test suite. So how can we handle those? How can we improve the maintainability of our test suite? Let's take a look here. What this is a very similar script to the one we recorded. However, here we've divided it up into multiple functions. So you can see our main function down below. In the main function, we're still starting the application, but we're taking a look and we are waiting for an object. Now this is something you'll notice throughout all of the scripts. Through the one that we recorded, wait for object is here. Through the one that I'm about to show you, wait for object is here. Now what is that doing? That is intelligently waiting for the object. And by intelligently, I mean it's taking a look, looking for this object. Remember, this is the symbolic name, so it's looking in the object map for the object. If it finds that object, it proceeds immediately. However, there's an optional parameter here in milliseconds. And the default value when that parameter is not specified is 20,000 milliseconds. So what that says is, okay, Squish, take a look. If that object's there, proceed immediately. However, wait a maximum of 20,000 milliseconds or 20 seconds to see if that object does appear. And once that object appears, proceed. And if it doesn't, return an error and let me know that it couldn't find the object. So this can be increased or decreased on a one-off basis. For example, you're rendering a large report, you're pulling a lot of information from a database. That may take a little bit longer. You can increase your default wait for object by simply adding that parameter there. But the 20,000 milliseconds, imagine waiting 20 seconds for an object. It's a significant time in application reaction for standard events. So that should be a fine default parameter for you. So we took a look, we're looking at an object, we're saving that object to a variable, and then what do we have here? Invoke a menu item, okay? File and new. Well, if you remember in our previous script, I went up and I clicked on a toolbar. Well, I also could have gone to the menu item. And that's something that's a common reoccurrence in this particular application. So what did I do? I extracted the steps from there, refactored them to be more usable for common situations. And now what I have is a function called invoke a menu item with two parameters, the name of the menu and the name of the item. And then we'll take a look down here. You'll notice this is not our symbolic name anymore. Now, we can use a symbolic name here for some items, or we can use a real name, but this gives a great example of using a real name in your script. So your real name is just like it appeared in the object map, the different properties. So this is of type Q menu bar, and it is visible. Okay, those two properties. But what is the actual menu we want to select? Well, we're passing that in as text. So as we have in this script over here, let's see here if we have file, open, right? So we're using the same object and passing in the string. But we've now refactored that to use an object's real name, passing in a parameter here, a variable, and then using that same variable, we now can dynamically build the next real name of that object and then select its item. So now anytime I want to use a menu, what am I doing? This line. Very simple. Saved myself time. If anything breaks in this area or changes that I need to adjust, I'm adjusting it in one area instead of 100 different locations where I may be using the same set. You can see here just in this script, it's being used 3 times in addition to the actual menu or function definition. So then we're going to go through another type of verification point, test.verify. Our last one was a test.compare, where it's taking a property value from this object and doing a comparison. Now it's important to understand not only do we have access to all the objects as you saw when I was creating those verification points, we also have access to the complete application's API. So row count of this property table. So QTable widget has its own methods, right? That part of that object. You have all of that available to you. So we've got the JavaScript syntax, the Squish API, and your application's API. So we're checking that the row count's equal to 0. Then we're iterating through an array that we've defined here, or defining an array, iterating through that, adding a new entry for each element in the array, and verifying the row count at the end and closing without saving. So again, I've refactored this to not only extract and reuse common items, but I'm also showing you a first level of maybe creating a data-driven script. So let's just run this here. And again, we have our verification points that it verified what I entered was what was expected. We have our true result showing here, and at the end, the same. Now, that's great, you know, an array, functions within the same test case. Well, this application is going to need to do a lot of those functions throughout the entire application, through multiple test cases, through multiple scenarios that you want to test. And maybe maintaining an array isn't really all that great because you're maintaining it directly from the script. So let's take a look at another example. Let's say that I have a set of functions common to my entire test suite. I can reference a file, whether that's from a global script over here, apologize, I just had to mute my phone there. Whether that is from a global script over here or a test suite resource, a script that is a Squish script, however common to my test suite. So if I come over here, again, I'm referencing common.js, which I've created in my test suite resources. I can take a look and you'll notice very similar functions, just a slight different function name over here. So I can reuse these throughout any test case in my entire test suite. If we take a look back at our script now, you can see the other functions are missing. This, because they're being referenced externally, this particular function I'm only using in this test case, so I'm not placing that as a test suite resource. And then instead of iterating through an array, I'm using an external data source. So in this case, a tab separated file. So if we take a look over in our test data, and you're able to use a test suite resource, test data from here, whether you're using a spreadsheet, an Excel spreadsheet, a CSV, TSV, or maybe a connection to a database. There's many different data sources that you can use. So here's my data. I'm then going to use this data in my script by retrieving information from that data set. And then iterating through, adding a name and address, and I did set a limit to 5 so that you don't have to sit through the entire address book being added to the application. But now we can see it running through this script. All right, many verification points. What started off as a very linear script going through adding one item, verifying it, now can verify an infinite number of items based on a data source. Now, another thing that's very common in enhancing or refactoring your scripts is also incorporating a little bit of error handling in them. For example, let's say that you have your wait for object and that fails. It didn't find it the first time. Okay, well, perhaps you want to handle that so that in the event it fails, you can either perform another check, maybe repeat that again, or return an error message and based on a message proceed differently, allowing your scripts to continue or moving past that particular script. So here up above, for example, this table is rendering. We're waiting for that table to be able to check the name and addresses. But the table's rendering, but that new entry may not always be ready. So there's multiple ways I could approach that. I could look to see if not only is the table ready, but the last record in that table ready. But just for a simple example here, what I did is I incorporated a try-catch statement. So I said, okay, try this comparison. In the event an error occurs, because let's say that that object just wasn't yet available, the table was available, but perhaps that new row wasn't available, so the text wasn't yet free. Catch that error, log the error because I want to know that that's occurring. Maybe I enhanced my script differently, or maybe I'm finding an issue in the application. I want to know that that error is occurring, and then I'm going to try it again. And if it fails that time, I'm going to have the script fail. So you're able to catch errors and proceed accordingly. Okay, so we didn't hit that. We didn't hit this error. As you can see, it's not logged in the script, but if that were to occur, it would catch that and proceed. Now there's some other neat features that we haven't gone over yet. Let's take a look back at our test case we created. And after we start the application, we're going to do a few things here. First of all, I want to show you how we can work with breakpoints, how we can step through our script, and then how we could also record steps that we may have missed during the initial recording. So I'm just going to call this, let's see if we have examples over here instead. We do. We'll go with this script over here. So we have this variable. It's a table. We're saving that. We're going to be able to work with that object. So let's go and we're going to double click here and set a breakpoint. So what I'm now going to be able to do is I'm going to be able to run this script to that line. So you might do this if you're encountering an issue, maybe your script is failing unexpectedly, or maybe you have some more steps you'd like to insert and record in here. So what happens when I hit this breakpoint after executing my script, any variables that appear in my script at this point in my script will appear off to the left here. I can see the variable. I can see the properties of those variables. The other thing that you can do, my script is paused. It's at a breakpoint. Perhaps I'm having trouble with a particular object. I can come over. I can select an object in my application, and I can look at that object. Another thing that you can do, let's say that, let me find this window over here. Let's say that you're interested in a particular object, or you're browsing through your application object tree, and you're not quite sure, so I'm navigating up the tree, which object this is, and how you can see that object. So you select that, and it's highlighting the object. So again, you can come over, you can select an object, you can select an object from the entire application object tree, and it will show you the object highlighted in your application. You can see all of those properties available to that object as well. So much as when we were creating our verification point, all of that data is available. Well, why is that helpful when troubleshooting? Perhaps here, row count was just not getting the information that I expected. So, okay, I'm able to see from my variable what I'm collecting. I'm able to see all of the different properties available. Properties in addition to this, so that are associated with your application's API, are also going to be available. And then I also have a script console over here, so that in the event I wanted to see, okay, if I have, we'll call this dummy 1, and I set that equal to the table object and click enter, I now have that saved in this variable. Well, what can I see about that particular object? Well, I can see its row count, 125. Okay, I'm able to see that. Perhaps if that were erroring, I would be able to see that that was a different result. Any type of command that the script could send, any type of method available from your API, you can input in here. This is a great way to just verify something that you may be scripting manually to make sure it has the expected result, or if you're having trouble finding an object, working through that, identifying what properties may need to change, you can find that object. Okay, so what else can we do from this standpoint? Well, we can step through our script. So whether we're stepping into or over items, especially if there's a function, it's going to execute those steps. And then also, other things that we can do, we can right-click, and I can record a snippet. So let's say I recorded some steps, and I forgot some steps that I wanted to record. Or I'm piecing together a script by adding logic around it and just recording segments of a script at a time. I can right-click, select record snippet, continue recording whatever steps I'd like. So now, because I didn't follow true logic in the order of my script, I'm going to be adding in some random steps here. I can click stop. Now, I interacted with a few new objects, so it's asking, do I want to reload my object map? That's fine. And then I could continue executing my script if I'd like, but the best thing to do after you've recorded some steps is to click stop the debugger, and see those new steps that I recorded. So it's nice, it's highlighting those steps that I recorded, so it's very identifiable between the other ones that I had that already existed. So you can see the different buttons I pressed, the text I entered, etc. So it went through those steps, and now I can play back my script, and if I've added these logically, then my script will play back without issue. Maybe I did them out of order. We can see that. So simply by clicking run, I can now have, and again, it's going to be difficult for you to see it that quick over GoToMeeting, but it did execute the steps that I inserted, and everything passed. So those are some nice ways to be able to walk through your script, add new steps to your script, especially when you're doing something like this where you're refactoring a script, you're creating functions. You can record small segments to create those functions. Many times you may create a large linear script and then extract them out to functions as well. Okay, a few more items I'll show here, and then we will open it up to additional questions. All right. Now, one of the things you can also do, I don't want to record, but I do want to play around in my application, and I want Squish to be hooked in so I can work with those objects. Well, if I simply click Launch AUT, it's going to launch my application. And a lot of those features that I had available when I was recording or when I was at a breakpoint then also become available. I can navigate my application object tree. I can highlight objects I'm interested in. I can also come over to my object map, and let's just have the object map large here. I can also come over to my object map, and I can begin looking to see, okay, perhaps I want to change the name of an object. I want to begin working with it. I want to include a wildcard or regular expression as this continually changes. So I can check the existence of an object, and it will tell me if it's there or not. Now, if you take a look, I don't have the address book, my address is open, right? It just says address book. So it's telling me the object isn't there. Let's change this just for a very quick test here to a wildcard. I'm going to check the existence again, and it can find that object. Okay, it found the object, great, but is it finding the object I think it is? Let's highlight the object. Okay, that's the object I wanted it to find. So that change I just made in my object map, I can now have confidence that that's going to work as expected. However, my symbolic name remained the same, so changes to my script are not necessary. I have my script as it is. Now, it's important to understand, and part of the best practices that we do incorporate through training and our documentation is that if you're going to make a number of changes like this to your object map, perhaps you also want to modify some of the naming conventions in here. As soon as you start modifying naming conventions of the symbolic names, it's best to do that early so that those are within your scripts. Now, an object moves, it changes. We can still handle that. We're not looking at a coordinate. We're not doing a pixel comparison to see where that object is. We are working with the actual objects. We're not interfering with your application, and we're able to create then robust scripts. So we'll go ahead and close that, return to my test management view, and that concludes the main portion of my demonstration, and we do now have 15 minutes left to open this up for additional questions. Again, it's best to ask the questions via the question answer area, and then we will get those answered for you. Another thing, if we return back to my slide deck here while you're looking at questions, a few things to reiterate. Again, cross-platform. We are one of the only tools out there that at the object level, not guessing by pixel, that you can work with applications across different platforms, operating systems, mobile devices, as well as simulators or emulators. Windows, Mac, Linux, etc., as well as all of those different technologies that we support across those, and hybrid applications. So you have a Qt application, perhaps you have Qt embedded, or you have a Qt application that's mixed also with some native controls depending on the operating system. We can handle all of that. Now you saw how powerful and easy to use it was. I was recording, I was playing back, I was able to go and enhance my object map, and I'm working at the object level. So I can create a lot of scripts, but I'm going to create robust scripts. I'm not going to create scripts that for each orientation and each different operating system, when you're working with Qt especially, I need to adjust my scripts for that operating system, or I need to have different captures of different potential dialogues in ImageBase across operating systems. No, we're working at the object level. You're creating one set of scripts, and those are going to work across all those operating systems that you want to test with your Qt application. And that applies to our other technologies as well. So we have record and playback, powerful scripting. You have complete access to your application's API. That interactive object spy that we saw throughout multiple use cases in the application. And then integration with a lot of those different ALM tools or build tools, etc., that you may be using to automate your process. Post build, do as we do internally. Kick off Squish scripts and verify your application is working, especially in an agile environment. That's very important. And then we do provide our source code to the customers so that you're able to make enhancements on your own as well, or build with your own specific DLLs. Now, following this webinar, you will receive follow-up email. You'll get access to download an evaluation. And then anytime you have questions or you simply want to reach out to us, squish@froglogic.com. During your evaluation period, you have complete access to our support. And then also go out to froglogic.com. We have a lot of information out there, white papers, customer stories, as well as at doc.froglogic.com, which I don't have listed here. I'll list that for you here now. Oops. And kb.froglogic.com. Those have a lot of important and useful resources for when you're using script, using our quick start tutorial, and as well as having common questions. So thank you very much for attending, and we will stick around to answer some more questions. And I look forward to seeing you when you are evaluating Squish.